Good evening. We're going to start our short unit on scientific notation, and we'd like to start you guys off with a few I can statements, a few positives here. By the end of this lesson, we're hoping that you'll be able to say these two things. I can express very large and very small numbers in scientific notation. Also, I can express very large and very small numbers in standard notation. I'm pretty sure you can already do the second one, folks, because all that's saying is these standard notation examples right here, okay, are expressed in standard notation. Standard notation is just how you would normally write a number, okay? 3 is how you would normally write the number 3, and 4.7 is how you would normally write the number 4.7, okay? However, when we pop over here to the right, we see that scientific notation examples are slightly different. Scientific notation is this form of writing a number that a lot of scientists use, and they use it to describe, or not describe, but to write very, very, very large numbers or very, very, very small numbers in a more condensed way. So 2.3 times 10 to the fourth, although it's not that big, this is just a basic example, that should come out and turn into, and maybe you guys have seen this in the past, 2.3 times 10 to the fourth is going to be 2, 3, and then 3 zeros. Oh yeah, I'm getting great at writing with this pen, folks. So this number right here is merely the scientific notation form of 23,000. Okay, and this number right here, as you notice, it has a negative exponent. That's actually going to represent 0.0061. Okay, so this right here is standard form, and this right here is scientific notation. Two different forms of writing a number. They're equivalent to each other. They're the same thing. Okay, if you notice, we've got a positive exponent up here in our first example, hence we have a larger number. Down here, we have a negative exponent, and what do you know? We have a smaller number. That's always going to be the case, guys. Alright, so something you should know about scientific notation. You should always write your numbers in scientific notation the same way. And what I mean by that is that if you notice, 4.3, okay, that number that's right there is always going to be a number between 1 and 10. So B/W means between 1 and, hopefully you can write this a little bit neater on your own in your own notes. That number is always going to be a number between 1 and 10. And if that number is not between 1 and 10, you need to move the decimal point so that it becomes a number that is between 1 and 10. And we'll talk about that a little bit more in a second. So your number is always going to be a number between 1 and 10, and then you're always going to multiply it, that's this times symbol right here, by a power of 10. In this case, it's 10 to the 5th power. So 4.3 times 10 to the 5th is a number written in scientific notation, which if you expanded it, it would be a much larger number because, if you remember, our exponent is positive. So you're going to move the decimal point to the right 5 spots. And I'll show you a little more about that in a second. Just for quick reference, if you see a number that looks like this, 0.2 times 10 cubed, and someone might be trying to trick you because they might say, hey, that's an answer and it's written in scientific notation. You should say, wait a minute, that's not proper scientific notation. The reason is 0.2 is not a number between 1 and 10. It doesn't fit the definition of a number that's written in scientific notation. So just as a good thing for your notes, you're always going to write a number between 1 and 10 times, that's a times symbol, a power of 10. Oh, come on, pen, you got to help me out. A power of 10. If you don't have this form, right here that I've just described, a number between 1 and 10 times a power of 10, then you do not have a number written in scientific notation. Okay? So, let's continue here. Let's move on to something else. So here we have a little table, and here you have the number written in scientific notation. And if you notice, right next to it we have the standard notation form, and some of you might be wondering, how in the world did he get this from this? Well, here you go. Scientific notation form, I'm going to do that top one, 3 times 10 to the negative second power, works like this. You can always, if that exponent is negative, just take your decimal point, which currently exists right here. This is like 3.0. You're going to move it to the left that many spots. So always remember, negative numbers, if you're going more negative, you'd move to the left, right? Fill in the open spots with zeros. And our new number, our number in standard notation, is 0.03, which is exactly what you have here. If you notice, 3 times 10 to the negative first is simply 3.0. And since your exponent is negative 1, we move the decimal point once to the left, we place it, and here's your number in standard notation. Okay, it's just 0.3. Let's continue. 3 times 10 to the 0. Well, guys, it makes sense that since 10 to the 0 must equal 1, you guys all know that, because anything raised to the 0 power is 1. This is just 3 times 1, and that equals 3. Okay, you all know that 3 times 10 is definitely 30. So this is just the opposite of the negative exponents. When you have a positive exponent with your power of 10, 3 times 10 to the first is like saying, well, I've got 3.0. If I multiply it by just 110, I'm going to move my decimal point once to the right. So my new answer for 3 times 10 to the first is 30. And one more time, we'll do this. 3 times 10 to the second. Okay, 3 times 10 squared. Well, guess what? How many spots do you think I moved the decimal? I'm going to move it 2 spots. And which way do I need to move it? Well, you should move it to the right, because since we have that positive exponent, we know we're going to have a bigger number when we write it in standard notation. So it's 3.0, but since it's 10 to the positive second, we're going to take that decimal point and we're going to move it 2 spots over, and our new answer is going to be 300, which really, once again, makes a ton of sense, because 3 times 10 squared is like saying 3 times 100, and of course that equals 300. So on your own, maybe consider this one, 3 times 10 to the 9th. What's that really asking you to do? If it asks you to write it in standard notation, well, you should probably move your decimal point, and I'll write it down here so you all can see. Since we have 3.0, okay, and then I'm multiplying it by 9 tens, I'm going to move my decimal point 9 places to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Place my decimal, and then fill in all those spots with zeros. I know, those are all the same size. So your new answer is 1, 2, 3, 4, 5, 6, 7, 8. Right now I have 9 zeros. So that means I have the number 3 billion. If I were you, I'd probably write that right in that box. Okay, let's do a few examples here. Express each number in scientific notation. Well, folks, if you noticed, here we went from scientific to standard notation. Now we're going to go the other direction. So if this is standard notation, in order to get something into scientific, as we said earlier, we need a number that's between 1 and 10. Since this ginormous number is not between 1 and 10, we need to take the decimal point, which currently sits right here, and we need to move it over until we have a number that's between 1 and 10. So make sure you count how many spots you move it over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Holy moly, we moved it over 11 spots. And how did I know where to stop? Because guess what? 9.156 is a number that's between 1 and 10. So I knew that's where the decimal point had to stop. So 9.156 times, well, if I can just get this pen to work here, times, and now I need a power of 10. So 10 raised to what exponent? And that's where you come back to, hey, how many spots did I move that decimal point over? And you all are thinking, well, you moved it over 11 spots. So it's 10 to the 11th power. And I know that it's a positive 11 because if I were to multiply this number that's in scientific notation and put it back into standard notation, I would have a very big number. Okay? So that means I should have a positive exponent. Now let's move down to number 2. Same thing. Do I have a number that's between 1 and 10? No, I do not. So let's take that decimal point and let's move it. 1, 2, 3, 4, 5. Oh, I got to stop right there because 3.28 is a number between 1 and 10. If I moved it one more right, I'd have 32.8, and that's far too big to be between 1 and 10. So 3.28 times, and we know it's got to be 10 to some power. The question is what? How many spots did I move it from here? 1, 2, 3, 4, 5. So I'm going to write a 5. Oh, wait a sec. You guys thought I was going to make a mistake, but I'm not. If I were to multiply this out, meaning I were to move this decimal point and turn this number back into standard notation, if I left it as a positive 5, that's really telling me that I need to move my decimal point to the right to get a really big number. And we know that that's not what this number right here is. This number is very small. So make sure that that exponent is negative. Okay, one more in this section. 23 times 10 to the third. Well, look at that. We're done. It's already in scientific notation. Just kidding, folks. Thought you had me there too, didn't you? Alright, so our decimal point is right after the 23. The reason this is not in scientific notation is because 23 is not between 1 and 10. And we've said repeatedly that you must have a number that's between 1 and 10. So let's take that decimal point. Let's move it back one spot. So that gives us 2.3. And of course, we need to multiply it by 10 to some power. Well, since I moved it back one, and when I multiply this out and turn it into standard form, I better move it 4 spots to the right to get a much bigger number. Okay? If I put a negative 4 up here, that should be a red flag because a negative means I'm going to end up with a lot smaller of a number. Okay, folks? So we're done with 3 right there. Now, this last couple, which, hey, look at that, I did make a mistake. That should say number 4. If we need to express each number in standard notation, it's a pretty quick fix. So here we have 2.9 times 10 to the third. Well, remember, all that means is, hey, move our decimal point 3 spots to the right since it's a positive number. So take our decimal and go 1, 2, 3, put down our decimal, put these zeros in here, and guess what? Our number right here in standard notation is 2900. And lastly, we have an example with a negative exponent. Okay, 3.7. Oops, I should give us more room here. Let me block that off. Sorry. 3.7. And since it's 10 to the negative fourth, which way do I move my decimal? Well, I should have a really small number once I get rid of my power right here. So that means I need to move my decimal 4 spots to the left. 1, 2, 3, 4. Put the decimal down. Add my zeros. And if you write really ugly and not very neatly, you might mess up these humps, so you might add an extra 0. So please be careful, take your time. Here we are, our answer should be 0.00037. This is standard form because we don't have any powers that we're multiplying it by. Alright guys, hopefully this video is helpful. We'll see you tomorrow in class after you complete our Google form. Have a great night.